Hello guys, welcome back to another video. In today's video I'm back with the part 19 for showing you my project I done so far. And in the last part video I finished showing you the audio detector. I think that's the project called, but I show you the audio that can detect the bird sound. And in today's video I'll continue the other project, and without further ado, let's get started. Alright guys, I'm back, and one thing to know that I'm sorry for misinterpretation for saying I finished explain this audio classification project, but I did not, and sorry for first I said I finished, but now let's continue from the last times we left off. Okay, I think I explained this one, also this one, and we plot this, and I show you until this one, and I show you also this one, and I think we can start from this one. Okay, after we process we create the function of pre-process function, we moved on to shuffle the positive data with shuffle size of 1000, and we also change it to numpy iterator just to visualize it, and we say dot next to grab some data just to help us to visualize some sample from the positive data, and then also we pre-process this grabbed data, and we just platter here, and this is what looks like when it is platted. And here after we did for one single data pre-process, we just after seeing what it looks like for one data, we just moved on and pre-process all data here, as you can see here, and we also shuffle and we specify the batch number to be 16, and then also we prefetch, and then we catch, and when we see the data it have 51 batch size, and we divided our data into train and test here, 36 of batch to be a train and 15 to be test. And here we also grab from some train data, and we see the shape, and it is 16 by 114 199 101, and it also have 257 by 1, and the label also, as you can see, it's just 0 or 1, and until here we just preparing the data, and here we start building the model. And to help us to build the model, we import sequential, conv 2D, and dense and flatten, and this is all the layers, and we build model like this. We just model the model to have a sequential value, the model variable, and we added layers after time, and the first one have conv 2D layers, the second one conv 2D, and we flatter and we have the next layer after flatter, it have dense layer, and in the last part we have dense of 1 one linear I'm sorry, not linear, layer of neuron. The last activation is sigmoid. If it is more than one layer of the last layer, it have to be softmax, because sigmoid is work only for classification. But if you are working with more than two classification tasks, it is have to be used as softmax. And for other layers we use ReLU, and the input shape looks like this, because we have here the input like this, and this 16 means we have 16 batch in one. We have 16 data in one batch. So, and here we compile our data by using Adam loss function. Adam compile, and we have loss of binary cross-entropy, and this is for binary classification. And we have matrix, and we have recall and precision, and run early to be true. And this is the summary of our modules looks like. And here we train our model, and we only do for 4 epoch, and we can see the history of the history variable of history, and we can just plot it. And we also saved here, and this is the losses looks like. And ideally this is what we want to do. We want to see the prediction to increase and the loss to decrease every single step. And this is also the recalls looks like. Okay, after that we say our model to load it. We just trying if the loaded model is work or not, and that's we did here. And we specify the x train and y test to be as numpy iterator of the test, and x test to be shape of to see the shape like this. And we just predict x test here, and we just see what the y hat or the predictor looks like, and this is what it predicted. And we use some code and to change if the value is more than 0.5 to be 1, and if it's less than 0.5 to be 0. And after we did that, when we see our y hat, it just only it will going to show us 0 or 1 of the value. And this is tools comparing just by running those two, and you can see manually by your eyes, or you can just use some code to make sure if the prediction and the real one is right, and it is true, it out true when we do that. And we write some code right here, and we import and I think okay, right. All right, I think after this I think just some kinds of code. I don't think it is okay. And this is the project it looks like. And I think we also import some from the first folder that I show you in the past part video. And we are just slicing the moment the model is detected the bird sound, and this is all the codes are going to do. And yeah, and I have some error. I think I did not finish the last part. As you can see, I just tap here, and but that's the last part that I was trying to do. And thanks for watching. If you are still here, thank you for watching, and I hope to see you in the next part video. And in the next part video, I'm going to start explaining the face detection project, and I hope to see you there. Goodbye.